All right, welcome to our 2.2 notes on compound inequalities. So today we're going to be able to solve and graph compound inequalities. So the first compound inequality we're going to talk about is and. So these are inequalities that are true only if both of the inequality portions are true. So if I said, if someone is wearing shorts and a hat, they have to be wearing both in order to be in that category. People who are wearing shorts but no hat, or hat but no shorts, they're not part of that group, right? We want to just talk about the places where they are both true. So we're trying to find out where the two graphs overlap. Okay, that's going to be, if you're part of this section and you're part of this section, here is where we're talking about that part where they're overlapping. Okay, the other type of compound inequality we have is the or. So if I said people are wearing shorts or a hat, you could be just in the hat category, just in the shorts category, or you could be in both, right? You're still going to be part of that group. So this is true if more than one of the inequalities are true, okay? So you could be in this category over here, this category over here. They could overlap, maybe they don't. Oftentimes you'll find that they don't overlap for inequalities, but it's true either way. So here's an example. So we know this is an or because it has the word or right in the middle, right? No tricks to it. It says or right there. So what we're going to do is we're just going to solve and graph both of these two inequalities and kind of put them together on one number line. So just do one at a time. So I'm going to start over here by adding 5 to both sides. That cancels these out. We get 2x is greater than 12. Divide by 2, divide by 2. Remember, if I multiply or divide by a negative, I switch that symbol around, but that's not the case here. So here's part of my inequality, right? I'm going to bring that word or right down here, okay? Now we're going to do the same thing on the other side. I'm going to add 1 to start solving this one, and I get negative 3x is greater than 9. And my next step, I'm going to divide by negative 3, right? So remember when we do that, we're going to flip this symbol. So it's going to become less than negative 3. So here are my two portions, right? So in order to graph this, I need to put these numbers on the number line. Make sure that when you do that, you're doing them in numerical order. So I'm going to put negative 3 on the left side and 6 is going to go on the right side, right? Because negative numbers would go towards the left, positive count up towards the right. So now I'm going to graph one piece at a time. So let's graph x is less than negative 3. So that's going to be an open circle to the left. And then we're going to graph x is greater than 6. So another open circle, but this one's going to go to the right because it's greater than. So that's my solution set. It's all of the numbers that are less than negative 3 or greater than 6, right? We can't have an and here because then we would have nothing in it. It would be a null set because there's no point where these overlap. So it's just the combination of less than negative 3 or greater than 6. It's both. Okay. This is another example, and this one is an and. I know it's an and because it doesn't say or. But what you can see here is that we have an inequality symbol here and we have an inequality symbol here. So we kind of are solving two inequalities at once. If I think about covering up the one on the left, we have really 2x minus 7 is less than 7. And I have 2x minus 7 is greater than or equal to 1. Those are really the two inequalities that we're solving. But because we put them together, it's implied that this is an and. So what we can do when we're solving these is we can solve them all at once. So we can add 7. I usually would say to both sides, but we're going to add 7 to all three sides. I'm going to get 8 is less than or equal to 2x is less than 14, right? These guys have canceled out. And then we're going to do the same thing. We're going to divide by 2, divide by 2, divide by 2. Okay, we're dividing by a positive number, so we're not going to flip our symbols. we're going to get x is less than 7 and greater than or equal to 4. So this is going to work the same way. I have to put my 4 and 7 on our number line, okay? We're going to graph the portion where these intersect. So where x is greater than or equal to 4, right? So I'm reading this from the variable. So I'm really reading this, okay? And x is less than 7. So greater than or equal to 4. So we're going to do a closed circle here. Less than 7, so open circle here. And we're talking about the place where they interlap. So if I think about this, right, I'm thinking about all of these numbers and all of these numbers. Do you see the portion where they overlap? It's this part right here, right? So the way that we're going to show that is just by kind of connecting those dots. It almost looks like a barbell, okay? So it's all the stuff in between 4 and 7, including 4, not including 7, but all the numbers in between are greater than 4 and less than 7. All right, here's a quick word problem. So when baking a cake, the cook time is between 19 and 24 minutes, depending on the pan used. Write a compound inequality to represent this. So there's a couple ways we could go about this, but we know our endpoints are 19 and 24. Okay. And we're talking about between, right? So is that going to be an and or an or? So it can be between, it can be 19, 20, 21, 22, 23, or 24. So it's going to be between 19 or 24. Now we just have to make sure we get the symbols right. So less than 24, right? It can be equal to, because usually if we say 19 to 24 minutes, 19 and 24 are fair game. And it can be greater than or equal to 19, right? So notice that the symbols are facing the same way, but when we read it from the variable, I'm really reading x is less than or equal to 24 and x is greater than or equal to 19, right? Because they're facing different ways with respect to x, but they're facing the same way on the page. All right, come back for more about absolute value inequalities.